A deep foundation is a system that transfers building loads to deeper, stronger soil layers or rock when surface soil is too weak. It extends several meters below ground, typically more than 3 meters, to reach adequate bearing capacity for structures like high-rise buildings and bridges. One key type is the pile foundation, which uses long, slender members made from concrete, steel, or timber. Piles are crucial for bridges, high-rise buildings, and areas with weak soil or waterlogged conditions. Next, pier foundations, also known as drilled shafts, are large-diameter cylindrical shafts drilled and filled with concrete. These are used for heavy loads, bridge piers, and where deep, stable soil layers are present. Caisson foundations involve large, watertight boxes or wells sunk into soil or water until they reach strong strata. Caissons are ideal for underwater structures like bridge piers and docks, as seen in projects like the Thames Barrier. In summary, when shallow soil is weak, deep foundations are essential for structural integrity.
A pile foundation is a type of deep foundation used when the surface soil is too weak or compressible to support the building load. It transfers the load of the structure deep into the ground to stronger soil or rock layers. These foundations consist of long, slender columns, called piles, made of concrete, steel, or timber. Piles are driven, bored, or cast deep into the ground to support the structure. The pile group carries the load primarily through two mechanisms: end bearing and skin friction. End bearing occurs when the pile tip rests on hard soil or rock, directly supporting the load. Skin friction transfers load by resistance along the pile's surface, especially in cohesive soils. Based on function, we have end-bearing piles, which act like columns transferring load to a firm layer. Friction piles rely on adhesion and friction along their surface, used when no hard layer is found at a reasonable depth. Other types include compaction piles to strengthen loose soil, tension piles to resist uplift forces, and anchor piles for retaining walls. Construction methods include driven piles hammered into the ground, board piles filled with concrete, and screw piles twisted into the soil. Pile foundations are crucial for bridges, high-rise buildings, marine structures, and areas with weak or soft soil.
A pier foundation, also known as a drilled shaft or drilled pier, is a deep foundation type designed to transfer heavy structural loads to strong soil or rock layers deep underground. This critical system is essential in areas with weak surface soils, preventing structural failure under load. Construction involves drilling a large diameter hole, typically 0.6 to 3 meters, then filling it with reinforced concrete. Key load transfer mechanisms include end bearing, where the pier rests on bedrock, and skin friction, where shear stresses along the pier's side provide additional capacity. There are two main types: drilled piers, used for land-based projects like bridges and tall buildings, and caissons, large watertight structures for underwater foundations. Advantages include high load-bearing capacity, minimal vibration during installation, and the ability to inspect the base before concreting. Pier foundations are widely used for bridge piers, high-rise building columns, transmission towers, and various industrial structures.
A caisson foundation, also known as a well foundation, is a deep foundation type for heavy structures, especially in water or soft soil. It's a large, hollow, cylindrical or box-shaped structure sunk into the ground or riverbed to reach strong soil or rock. Key characteristics include being typically made of reinforced concrete, sometimes steel or timber. It's constructed above ground and then gradually sunk to the required depth, with internal soil excavated as it sinks. Once a firm stratum is reached, the hollow interior is filled with concrete to form a robust foundation. There are three main types: open caisson, box caisson, and pneumatic caisson. An open caisson has no bottom and sinks as soil is removed from its interior, commonly used in rivers and deep soil. A box caisson has a closed bottom and is lowered into prepared underwater pits, not typically for very deep foundations. A pneumatic caisson uses airtight working chambers and air pressure to keep water out during excavation for very deep underwater works. Caisson foundations are widely used for bridge piers, dams, ports, harbor structures, deep water foundations, and large river crossings.
A basement foundation is a deep foundation system where the building has a below-ground floor that also acts as the foundation structure. It supports the building loads while providing usable underground space, constructed using deep strip footings or a deep mat foundation. The deep strip basement foundation uses continuous concrete strip footings built below the basement walls. This system supports load-bearing basement walls and is common in residential buildings where soil is strong and loads are moderate. A basement mat, or raft, foundation involves a thick reinforced concrete slab built under the entire basement area. It supports all walls and columns of the structure, ideal when the soil is weak or loads are heavy, distributing weight evenly. Basement foundations offer extra usable space, provide good stability, and can resist lateral soil pressure with reinforced walls. They are used for high-rise buildings, residential buildings with basements, commercial structures, and those on sloping ground. Understanding these foundation types is crucial for civil engineering professionals and construction enthusiasts alike.